I know many of you aren't done yet, but let's take a look and see how you're doing on these conversions with the ones you have done so far. Number one here, this is standard units going from rods to yards. So I'll start out with my 4 rods, and I'm going to make it a fraction by putting it over 1. So in my conversion factor, I'm going to put rods on bottom so they will cancel out. 1 rod equals 5.5 yards, or 5.5 yards. So here the rods cancel out. 4 times 5.5 yards is 22 yards. On bottom, we just have 1 times 1 is 1. The 22 yards over 1 is just 22 yards. For number 2, for the metric conversion, we need a little chart. We've got meters, decimeters, centimeters, millimeters. We are going from centimeters to meters. So from centimeters to meters is 2 spots to the left on our chart. So our decimal point has to move 2 spots to the left. Well, there's no decimal point in the 7600s. That means it's at the end of the number. We move it 1, 2 spots to the left. 7,600 centimeters is 76 meters. For number 3, 324 inches. Put that over 1 to make it a fraction. I'm getting rid of inches, so I'm going to put them on bottom. We did not give a direct conversion from inches to yards. Now, many of you probably know that it's 36 inches, but for now, let's go through feet. I know that 1 foot is 12 inches. Now, the inches have canceled, and now we're in feet. So now I want to go the next step, which would be to cancel the feet and go to yards. 1 yard is 3 feet. So the feet cancel out, and we are now in yards. So on top, we have 324 times 1 yard. That's 324 yards. On bottom, we have 1 times 12 times 3, which is 36. So 324 yards divided by 36 is 9 yards. So 324 inches is 9 yards. Number 4, we are going from meters to millimeters. From meters to millimeters is 1, 2, 3 spots to the right on our chart. So our decimal point has to move 3 spots to the right. We go 1, 2, we have to add a 0, so we can go 3. 0.43 meters is 430 millimeters. .4 miles. Going into feet. We'll put miles on bottom so they cancel out again. Feet on top. 1 mile is 5,280 feet. So the miles will cancel out. 0.4, 5,280 is 2,112 feet. On bottom, 1 times 1 is just 1. So 0.4 miles is 2,112 feet. And finally, number 6, 31 feet. Going into inches, we'll put feet on bottom so they cancel out. 1 foot is 12 inches. So the feet cancel. 31 times 12, well, what is that, 372 inches. 1 times 1 is 1. So 372 inches over 1 is just 372 inches. Any questions on those? Hopefully at this point you're starting to see, as you get used to the metric units, you're starting to see that those units are a lot easier to work with. We tend to be shy away from them just because we're not so familiar with them. But once you get used to them, the conversions are very simple. And what we look at today, we're going to see that they're a lot simpler as well to work with our operations with measurements. So we're going to start off looking at standard measurement a little bit more today. More of the standard lengths. In fact, with many of our standard units, we use what's called a dual or multiple unit system. What that means is if I have something that's 3 feet 7 inches, I use both of those units in conjunction to describe the length of that object. Why do I do that? Well, when we do measurement, there's two things we try to avoid. We try to avoid really large numbers. If I convert that into all inches, I have to do 3 times 12 is 36 inches, plus the 7 is 43 inches, which isn't a really huge number, but it's a big number. Now you'll notice what I did there, by the way. That was a lot like what we did with our changing our mixed numbers to improper fractions. When I see something like 3 feet 7 inches, that 7 inches is 7/12 of a foot. I can actually work with it as 3 7/12. If I want it to be totally inches, I do that exact process. I convert it to an improper fraction. 3 times 12 is 36. I add that 36 back to the 7. That's 43/12 of a foot, or 43 inches. So we try working with larger numbers if we can avoid it. And 43 is, like I said, not huge, but it's big enough. The other thing we try to avoid, if I wanted to convert that all into feet, well, it would literally be 3 7/12 feet. Or if I wanted to turn that into a decimal, 7/12, of course, is 0.5833333. That'd be 3.58333333, repeating, feet. Well, that's the other thing we try to avoid. We try to avoid either ugly fractions or repeating decimals or ugly-looking decimals. So because we avoid those two things, we tend to stay with our dual units. Because if we get up to, 15, 20 feet with inches left over, we don't want the ugly fraction of a foot, but we also don't want to have 200 inches either. We want to be able to break it up a little bit more reasonably than that. Well, because of that dual unit or multiple unit system, it complicates our operations with standard lengths. We might have something like 5 feet 8 inches plus 2 feet 3 inches. Just like any other addition, whether it were mixed numbers for fractions or even just whole numbers, we line up the place values. In this case, our place values are the units. So inches line up with inches, feet with feet. And we can only combine things that have the same name or the same place value. Just like all of our other operations, all of our other additions, we start on the right and we work our way backwards to the left in case we have to carry. What's different is the number that we have to carry at. Here, we add 8 inches plus 3 inches is 11 inches. We don't have to carry yet because we haven't hit 12 inches. We have to hit 12 inches before it's a full foot. So we can have 11 inches in our inch place there. Then we do the 5 plus 2 is 7 feet. That's 7 feet 11 inches. Now, of course, it doesn't stay quite that simple. We might have 7 feet 6 inches plus 4 feet 11 inches. Again, we're lined up, inches with inches, feet with feet. We're going to start on the right, work our way back to the left. But now we have 6 inches plus 11 inches is 17 inches. That is more than a foot. So kind of like with what we did with fractions, we're going to break that up. 12 goes into 17 once. That's 1 foot with 5 left over. That's 5 inches. So we keep the 5 inches and we carry the 1 foot. 1 and 7 makes 8, plus 4 is 12 feet. So that's 12 feet 5 inches. Well, we can work with more than just feet and inches. We might have 4 yards, 2 feet, plus 7 yards and 2 feet. Start on the right, work our way back to the left. 2 feet plus 2 feet is 4 feet. Well, that's more than a yard. 1 yard is 3 feet, so it's 1 yard with another foot left over. So we keep our 1 foot, we carry the 1 yard. 1 and 4 is 5, plus 7 is 12 yards. We might have 4 rods and 3 yards, plus 2 rods and 5 yards. Now I realize the rods and yards are not something we're horribly familiar with, but remember 1 rod equals 5.5 yards. So we start on the right, work our way back to the left. 3 plus 5 is 8 yards. Well, that's bigger than a rod. We can get 1 rod out of there. 8 minus 5.5 is 2.5 yards left over. We're going to keep our 2.5 or 2.5 yards and carry our 1 rod. 1 plus 4 is 5, plus 2 is 7 rods. So 7 rods, 2.5 yards. We might have 4 yards, 2 feet 9 inches, plus 2 yards, 2 feet 7 inches. And again, we're going to start at the right, working our way back to the left. Now we have a triple unit, 3 units to deal with. Well, 9 inches plus 7 inches is 16 inches, which is more than a foot. That is 1 foot. Take away 12 with 4 inches left over. So I'm going to keep my 4 inches, carry my 1 foot. Well, adding there, 1, 2, and 2 is 5 feet. Move it down just a hair. 5 feet is bigger than a yard. There's 1 yard in there. The 1 yard is 3 feet, so there's 2 feet left over. So I'll keep my 2 feet, carry my 1 yard. 1 and 4 is 5, plus 2 is 7. That is 7 yards. 7 yards, 2 feet, and 4 inches. I want you guys to try this one in your notes. Five yards, 2 feet, 5 inches. Plus 3 yards, 1 foot, and 11 inches. I'll give you about 30 seconds, then we'll go over it. So, again, we start on our right, work our way back to the left. 5 inches and 11 inches is 16 inches. That's more than a foot. That's 1 foot, 4 inches left over. So I keep my 4 inches, carry my 1 foot. 1, 2, and 1 is 4 feet, which is bigger than a yard. So that's 1 yard. The 1 yard is 3 feet, so there's 1 foot left over. So I keep my 1 foot and I carry my 1 yard. 1, 5, and 3 is 9 yards. 9 yard, 1 foot, 4 inches. When we subtract, we follow the same rules. We can only combine things that have the same name. So we line up our columns. Inches with inches, feet with feet. So 7 feet 9 inches minus 2 feet 5 inches. We're going to start at the right and work our way back to the left again, like we do with all other forms of numbers. 9 minus 5 is 4 inches. 7 feet minus 2 is 5 feet. So 5 feet 4 inches. Again, it doesn't always stay that easy. We have something like 8 feet 2 inches minus 5 feet 11 inches. We go to subtract here. We cannot do 2 inches minus 11 inches, so we have to borrow. We borrow from the 8 feet. That becomes 7 feet. Well, what we borrowed was 1 full foot, which contains 12 inches. 2 inches plus 12 inches is 14 inches. Kind of like with fractions again, when we borrowed, we have to make sure we know how many pieces are in that larger object we borrowed. Now 14 inches minus 11 inches is 3 inches. 7 feet minus 5 feet is 2 feet. 2 feet, 3 inches is that measurement. We might have 7 yards, 1 foot, minus 3 yards, 2 feet. But once again, 1 foot minus 2 feet can't be done, so we're going to borrow from the 7 yards. That becomes 6 yards. Well, that 1 yard contains 3 feet. So 1 plus 3 is now 4 feet. Now 4 feet minus 2 feet is 2 feet. 6 yards minus 3 yards is 3 yards. It's 3 yards, 2 feet. Well, next might have something like 7 rods, 2 yards minus 2 rods, 5 yards. Again, we cannot do 2 yards minus 5 yards, so we're going to have to borrow. Borrow from the 7 rods, that becomes 6 rods, and 1 rod contains 5.5 or 5.5 yards. So 7 plus 5.5 is 7.5 yards. Now 7.5 minus 5 is 2.5 yards. 6 rods minus 2 rods is 4 rods. We'll do one more of those just because we're not terribly familiar with the rods in yards. We might have 9 rods, 1 yard, minus 3 rods, 3 yards. Well, again, 1 minus 3 can't be done, so we're going to borrow from the 9. That becomes 8 rods. Again, that adds 5.5 yards to the 1, so it's now 6.5 yards that we have. 6.5 minus 3 is 3.5 yards. 8 minus 3 is 5 rods. We might have 7 yards, 1 foot, 3 inches. Minus 2 yards, 2 feet, 9 inches. So again, we're going to start on the right, work our way back to the left. 3 minus 9 can't be done, so we're going to borrow from our foot. That's now 0 feet. We add 12 to our 3. This is now 15 inches. 15 inches minus 9 inches gives us 6 inches. Well, our 0 feet minus 2 feet can't be done, so we're going to borrow from the 7 yards. That's now 6 yards. Well, 1 yard is 3 feet, so 0 plus 3, we now have 3 feet. 3 feet minus 2 feet is 1 foot. 6 yards minus 2 yards is 4 yards. 4 yards, 1 foot, 6 inches is our measurement. In your notes, I want you to try 8 yards, 7 inches, minus, I'm giving it to you in a little bit different format because I want to see if you can figure out how to set it up. 3 yards, 1 foot, 10 inches. 8 yards, 7 inches minus 3 yards, 1 foot, 10 inches. See if you can figure out how to set it up and then do the subtraction, and then we'll go over it in a minute. So when you set this one up, even though there's no feet in that first number, we have to put 0 feet in there just to hold the place so that we can line up feet in the second number with 0 feet. We got to have something to line that up with. So we have to put in the 0 feet. So now we go to subtract. 7 minus 10 can't be done, so we're going to have to borrow. But there's nothing here to borrow from. So we go to our next unit. The 8 yards, we borrow, that becomes 7 yards. This now becomes 3 feet. Now we can borrow from that 3 feet, it becomes 2 feet. And we add 12 inches over here. That now is 19 inches. Now we're ready to subtract. 19 minus 10 is 9 inches. 2 feet minus 1 foot is 1 foot. 7 yards minus 3 yards is 4 yards. They're kind of like with decimals when we had a lot of zeros there, a lot of extra decimal places. You might have to borrow multiple places over in order to find something that we can use. Here there was nothing here, so we had to go one more place over, and we had to do borrowing twice to get this number increased to where we could subtract. Multiplication with measurements can take on 2 different forms. One is a measurement times, the technical term for it is a scalar. Well, all a scalar is it's a count. It's not a measurement. Or we can do a measurement times another measurement. A measurement times a scalar or a count is just saying I have something that is 4 feet 5 inches long and I need 6 of them. That is a measurement times a scalar or a count. We're going to come back to that in a second. A measurement times a measurement, we might have 2 feet 6 inches times 3 feet 9 inches. Well, if we were to try to multiply that out the way it is, remember when we did our mixed numbers with fractions, we did that one example, we would have to do 9 times 6, that's 54 square inches, but we'd also have to do the inches times feet. Remember, when we multiply, we don't need the same name. So every digit of one number has to combine with every digit of the other. Well, 9 inches times 2 feet gives us 18 foot inches. Now, a foot inch or an inch foot, however you want to pronounce it, is actually a unit. It's just we don't have any practical applications anymore. It used to be used. It was a strip that was 1 inch wide and a foot long, but it's just not used in application anymore. Either way, we'd end up with a mixture here of square inches, inch feet, and square feet. We don't want that conglomeration of units. We could convert them so that we could get them all into one unit when we were done, which is what we would have to do to really be useful. To get it into a single useful answer, we'd have to convert it either all into feet or all into square feet or all into square inches, which gets messy and makes it a difficult process. So kind of like what we did with our fractions, where we didn't work with the mixed numbers, we turned them into improper fractions. Same type of thing goes with measurement. If we're multiplying two length measurements, we're either going to convert them all into inches or all into feet. Well, first of all, let's go over converting these into inches. I'm going to convert them all into inches. 2 feet, 6 inches. Remember, we think of it kind of like that mixed number. It's 2 times 12 is 24. 24 plus 6 is 30 inches. We do the same with the 3 feet, 9 inches. 3 times 12 is 36, plus 9 is 45 inches. Multiply those out. 30 times 45, I believe, is 1,350 square inches. If I wanted to change them all into feet, again, we just think of them like those mixed numbers. 2 foot 6 inches. Well, there's 12 inches in a foot, so that's 2 6/12 of a foot, or 2.5 feet. 3 foot 9 inches, that's 3 9/12 of a foot, or 3 3/4 feet. I multiply those out, I get 9.375, or 9 3/8 square feet. Now, first of all, let's look at that for a second. 9.375 square feet and 1,350 square inches. If I take that 9.375 times 12, which is how we convert feet to inches, I get 112.5. That is not 1,350. Well, the reason is these are not feet and inches, it is square feet and square inches. If I actually multiply that a second time, multiply by 12 again, I do get the 1,350. Our conversion factors are different when we look at square inches. And it makes sense because square inches and square feet are different units from linear inches and linear feet, which is our normal inches and normal feet. So in a couple of classes, we will come back and we will look at those conversions, how they change when it's squared units or cubed units. For right now, when we do operations with measurements, when we multiply, we're only going to do multiplication with a single unit at a time. We're not going to do the dual unit multiplication. So now let's go back and look at that length measurement times a scalar. So if I have something that's 5 feet, 7 inches long, and I need to have 9 of them to get a total length. Now we could convert the 5 feet, 7 inches all into inches, to be 67 inches and multiply it out. But that makes us work with some really large numbers. So let's try to do it with the dual units. Just like any other multiplication, we start on the right, we're going to work our way backwards to the left. We do 9 times 7 inches, which is 63 inches. Well, that is more than a foot. 12 goes into 63 5 times. 5 times 12 would be 60. There's 3 inches left over. If you have a hard time with that calculation, do it out as long division, just like we did when we did our mixed numbers, or converting improper fractions back to mixed numbers. 12 goes into 60 5 times, or 63 5 times. 5 times 12 is 60. There's 3 left over. Well, the 5 is our feet. The 3 is our inches. 5 feet, 3 inches. So we're going to keep the 3 inches, and we're going to carry the 5 feet. So now we do 9 times 5, which is 45. Then we add the 5 that we carried. Makes that 50 feet. That is 50 feet and 3 inches. We might have 7 feet, 8 1/4 inches, times, let's say we need 7 of them. So we have to do 8 1/4 times 7. That is 57 3/4 inches. Now again, we need to figure out how many whole feet that is. 12 goes into 57 4 times. 4 times 12 is 48. So if I subtract 48, I'm left with 9 3/4 inches. So I have 9 3/4 inches here. Carry my 4 feet. 7 times 7 feet is 49, plus 4 is 53. Or we might have 4 yards, 2 feet times, well, let's just go times 5. So we need 5 of them. 5 times 2 feet is 10 feet. Well, that is more than a yard. 3 goes into 10 3 times. That's 3 yards. 3 times 3 is 9, so there's 1 foot left over. So we keep our 1 foot. We carry our 3 yards. 5 times 4 is 20, plus 3 is 23. And of course, we can hit our dual or triple units if we want to. 3 yards, 2 feet, 9 inches. And let's say I just need 3 of those. Well, 3 times 9 is 27 inches. 12 goes into 27 twice. That would be 24. So 27 minus 24 is 3 inches left over. So we'll keep our 3 inches here. And we'll carry our 2 feet. Now we have 3 times 2 is 6, plus 2 is 8 feet. Well, that's 2 yards. 3 goes into 8 twice, and with 2 feet left over. So we'll keep our 2 feet. We'll carry our 2 yards. 3 times 3 is 9, plus 2 is 11 yards. Division is the one operation where we start on the left and work our way back to the right. Let's say I have 19 feet, 8 inches, and I want to cut those into 4 equal pieces. Yes, we could convert that all into inches, divide it out, and convert it back into feet and inches. On a quiz or test, if you give me the answer all in inches, I will take off half of the points. If it starts out as a combination of feet and inches, the answer should come as a combination of feet and inches. So if you do convert it all into inches, make sure you convert it back into feet and inches, just so you're aware. So we can just divide this going left to right. 4 goes into 19 4 times. Well, 4 feet times 4 is 16 feet, giving us 3 feet left over. Now here, before we bring down the 8 inches, I have to convert these 3 feet into 36 inches. Now, when I bring down the 8 inches, I combine them with the 36 inches to make 44 inches. Now 44 divided by 4 is 11 inches, and that's it. 11 times 44 is 44. There's nothing left over. We might have 36 feet 2 inches divided by 7. So we're going to do the same thing. 7 goes into 36 5 times. 5 feet times 7 is 35 feet. We subtract, we get 1 foot. Now again, before we bring down the 2 inches, I'm going to turn my 1 foot into 12 inches. I bring down my 2 with it, it's 14 inches. 14 divided by 7 is 2 inches. So 5 feet 2 inches. Any questions? Now in the metric system, we do not have these dual units. You would never see something listed as 2 meters and 47 centimeters. You just would never see it. They don't do that because the conversions are so quick and simple in the metric system. This can either be neatly written as 2.47 meters or 247 centimeters. Now the 247 centimeters is getting pretty large, but the 2.47 meters is a pretty neat decimal. We don't run into that continuing decimal or non-terminating decimal or repeating decimal. It's a nice, neat conversion. So because of that, we never use more than a single unit to describe something in the metric system, which means when we go to do an operation, if I have something like 4.7 meters plus 340 centimeters, let's put my 0 in there, I either have to convert everything to meters or everything to centimeters. To figure out which, we look at what we want our answer to be. If we want our answer here to be centimeters, then I'm going to convert my 4.7 meters into 470 centimeters. I'll add that to the 340 centimeters, which gives us 810 centimeters. So it's just a matter of making sure you have the same units in the metric system, and then combining the units, and then doing the appropriate item with the names. If I have 6 meters times 5 meters, remember 6 times 5 is 30, meters times meters is meters squared. I could have 6 meters times just 5 as a scalar. Well, now it's 6 times 5 is 30. Meters times nothing is just meters. Or I might have 6 meters squared times 5 meters. 6 times 5 is 30. Meters squared times meters is meters cubed. I have to keep that in mind when I go to divide. If I have 24 meters divided by 6, well, 24 divided by 6 is 4. Meters divided by nothing just stays meters. But if it's 24 meters divided by 6 meters, well, now I have 24 divided by 6 is 4. Meters divided by meters cancel out. So the difference is this one is saying I have 24 meters of a material. If I cut it into 6 equal pieces, each piece is 4 meters long. This is saying I have 24 meters of material, but I'm cutting it into pieces that are 6 meters long. I can get 4 pieces. And we can also have 24 square meters divided by 6 meters. So again, 24 divided by 6 is 4. Meters squared divided by meters is just meters. So make sure you are aware of those units when we're multiplying and dividing to see if we have to deal with the powers. So we are still working in that packet that we started on Thursday. On page 237, numbers 13 through 24, do all of those. And page 265 in that packet, numbers 15 through 22, do all of those, please, where we are doing operations with our measurements. Okay, we have about 6 minutes left here, so if you'd like to get started on the homework, you can have that time to get started. I will be on the network here to answer questions. Otherwise, if you would like